Welcome back, our dear viewers and learners, to this presentation, where we are going to introduce the topic called expansion. Remember, the subject is physics. Physics is a very, very important subject. I was trying to look at the body which normally admits students in universities, called COOPs, or we call it COOPs. You find that physics is a requirement in majority of the courses. Physics is a requirement. If a student does physics, then he or she will have a bigger scope when it comes to selecting the courses. So right away, I want us to introduce the topic, and in our introduction, remember the topic is expansion and contraction. In our introduction, we are supposed to have some key things which we are going to encounter in this topic. Number one being to know what temperature is. So when you talk of temperature, temperature normally is the degree. This is the degree. When you talk of the degree, then essentially you're just talking of the extent of hotness or coldness of a body, and normally this temperature is normally obtained from a scale. That is, it is normally obtained from a scale, or that is from a chosen scale. So that is what you call temperature. So when you talk of temperature, the temperature is normally measured using the thermometer. It is important for you to know that we use the thermometer to measure temperature. It is measured using a thermometer. It is measured using a thermometer. We are going to meet the thermometer. We will even see how to come up with a scale of a thermometer. So that is very, very important. Then it is also important for us to know, just from the concept that we learned under measurements at the time when we were looking at the quantities that we have. We had the 7 basic physical quantities, also called the fundamental quantities, and what we call the derived quantities. So we found that temperature, or what we call the thermodynamic temperature, is among the basic physical quantities, and we said that thermodynamic temperature, it is normally it is a basic physical quantity, the way I've said, and it is normally measured, that is in Kelvin. So the SI unit, its SI unit is Kelvin. Its SI unit is Kelvin, abbreviated as K, or the symbol for Kelvin is K. So having looked at the meaning of temperature and how it is measured, and even the instrument, many a times we've had confusion, students confusing between temperature and heat. When you talk of heat, is heat the same as temperature? So that is what I just want us to discover. So when you talk of heat, normally when you were giving the definition of heat, we say that heat is a form of energy. This is a form of energy. It is a form of energy. Let me use a different color or a different pen, so that we can have something which we are able to see. So I've said that heat is a form of energy. It is a form of energy. That is a form of energy. Heat is a form of energy. Is a form of energy. Is a form of energy. That is which moves from a region. It normally moves from a region of high temperature or higher temperature. Higher temperature, we are talking of higher temperature to lower temperature. It normally moves from a region of higher temperature. So as we are mentioning heat, it must be that there is temperature. So the two are not the same. As you can see, the two are not the same. To lower temperature until an equilibrium, is reached. Until an equilibrium is reached. So that is what we are saying there. That when you talk of heat, then in essence you are talking of the form of energy which moves from a region of higher temperature to a region of lower temperature. So in essence, we are meaning that heat and temperature are not the same. That is what you are supposed to mean. I hope from today there will be no more confusion. So we are talking of, if you are having two bodies here, take an example. One body is at a temperature, let's say 100 degrees Celsius. Another one is at a lower temperature. It is at a lower temperature, or we can say maybe it is at 0 degrees Celsius. So what will happen is that the heat will move from this region of high temperature to the region of low temperature until an equilibrium is reached. So this is a movement of heat. So that is what we are getting here. So we have, at the end of everything, the end result. So when the two now are at the same temperature, we say that the two bodies are at equilibrium. So there will be no further movement of heat. So we can talk of maybe the temperature at equilibrium, let's say it is at 50, assuming there is no heat loss, to the environment. So for this case, there will be no movement. Essentially, the temperature this side is the same as the temperature that point. So this one is when it is moving, then they are at equilibrium. The two bodies are at equilibrium. So that is what we are saying. Then also the unit or the SI unit of measuring heat is not the same as that one for measuring temperature, because we know that the SI unit, so that is its SI unit. Is joules. We use capital H, capital J if it is the symbol. But if you're writing, then you make sure that you write joules in small letters. Having looked at that now, so these are the basics that we are going to meet in or which are very important as far as our topic is concerned. And so right away now, I want us to begin looking at the serious work. Remember, the topic is expansion and contraction. So what is expansion and contraction now? So the expansion, I want us to go through the subheading expansion and contraction, so that also we can know their different meanings. That is very, very important. So as we have gone through this, I can only assure you that these are the terms that we're going to meet as far as our subheading is concerned, or essentially as far as the topic is concerned. We will have temperature, we will have the thermometer, we will have the units like Kelvin and etc. So that is what we are having there. So when you talk of expansion, when you take like a metal and you heat it, you will find that metal increasing in size. It will increase in size and also in shape. It will increase in size and also in shape. So that increase in size and shape, that is what we are calling expansion. That is what you need to know. So metals other than and other solids, so that is metals and other solids, metals and other solids will expand. So that is they expand. And when you're talking of expand, you are essentially meaning increase in size. They are going to increase in size. And this increase in size might be it is increasing in length, and even sometimes it can increase cross-sectionally. It can also increase cross-sectionally. That is very, very important. So that is when heated. When heated. So when a metal surface or other solids, remember not all solids will expand, because we also have what you call the poor conductors, or we are talking of poor materials which cannot expand. There are materials which cannot expand, and we have solids which can expand. We are going to have the list, and I hope you will be able to understand. So metals and other solids expand, that is, will expand. And when you talk of expand, you're essentially meaning increase in size when they are heated. At the same time, they will contract. They will contract and contract and contract. And when you talk of contract, essentially we are meaning decrease in size. The opposite of expand. The opposite of expand. And this one normally happens when they are cooled. That is, when their temperature is reduced. That is, when cooled. When cooled. So this is, in essence, what we are going to have. That we are going to have materials increasing in size when the heat, when they are put or when they have been injected on the heat, or the other materials, or the same materials, you'll find them decreasing in size when their temperature has been reduced, or in essence, they have been cooled. So this is essentially what we are going to have in our topic. Or in essence, the topic expansion and contraction, it entails where there is heat, there is expansion, and where there is a cooling or reduction in temperature, there is a contraction. And contraction is the reduction in size, and expansion is the increase in size. That is what we're having there. So we also have experiments which can help us to investigate. We have experiments which can help us to investigate expansion. Experiments which can help us to investigate expansion when it comes to in solids. When it comes to the solids, so expansions, experiments, rather, the experiments. So we are writing experiment. Experiment. I want us to go through this experiment to demonstrate. To demonstrate expansion. To demonstrate expansion of solids. And in the first case here, I want us to use number one. We are using what you call the ball. We want to use the ball and ring experiment. We are using what you call the ball and ring experiment. So as usual, having the experiment, we must have the apparatus. So we have the following apparatus. What you need the ball. You need the ball and ring apparatus. This is the first one. And it is important for us to say that the two are supposed to be at the same temperature. They are supposed to be at the same temperature. That is, at that room temperature, it should be in such a way that the ball just passes. the ball just passes. That is very, very key. So we are saying that NB here, NB, the ball should, so that is the ball should be such that it just passes. It just passes through the ring. It just passes through the ring when both are at room temperature. When both are at room temperature. When both of them are at room temperature. So that is the condition. It just passes. So that is what we have in there. So this is the setup, the ring. We have the ring here. We have the ring, and the ring normally it has a handle. It has a handle. The ring has a handle. The ring has a handle. So that is the handle. Then we have the ball. So we have the ball here, and this ball is connected with a chain. It's connected with a chain. It is connected with a chain. And remember, we said it is a ring. It is ball and ring apparatus. They are essentially together. So this is the chain. So that is the chain, and this is the ball. This is the ball. Then this is the ring. So that is essentially what we have in here. And remember, this is the handle. And given that we are dealing with heat, then you must make sure that your handle should be a poor conductor of heat. It should be a poor conductor of heat. Like for this case, you can use plastic. You can use wooden material. Essentially, you use the poor conductors of heat. So that is what we have in there. Then in the procedure, this is what you're supposed to do. In the procedure. So in the procedure, we have the following. In the procedure, number one is that you hit the ball and try. Hit the ball. You hit the ball. We have not said you hit the ring. Hit the ball and try. That is to pass it through the ring. Try to pass it through the ring. Try to pass it through the ring. Then what are you going to see? So observe what happens. Observe what happens. Number two is that you leave it there for some time. You leave it there for some time. Where are we leaving it? We leave it on the ring. And also observe what happens. So observe what happens. So what are we going to see? What happens? Observe what happens. So what are we going to see here? So we are talking of the observations. What will be the observations? So observations are supposed to be given just according to the activity that you have done. So like for this case, the first activity, we want to hit the ball and you try to pass it through the ring. So you are going to realize that at room temperature, so that is what we saw. That is at room temperature, it just passes in the observation. Remember that one also you ought to have made that observation. So at room temperature, At room temperature, the ball just passes. Just passes through the ring. It just passes through the ring. Then what about when you heat? So when the ball is heated, you will find that it does not go through the ring. So when heated, it doesn't go through. It doesn't go through the ring. It doesn't go through the ring. So that is according to the first procedure that we had. What about the second procedure? So when you leave it for some time, you will see it passing through the ring. When left for some time, it passes through the ring. It passes through the ring. What is the explanation? So I want us to go through the explanation, and even we shall have conclusion also. What is the explanation? So why is it that when you heat it, it doesn't pass? So when the ball is heated, it increases in size. It will increase in size, and hence it doesn't pass through the ring. It doesn't pass through the ring. So the reason why it is not passing through the ring is because it has increased in size. So it increases in size. That is what we are getting there. Then why is it that after some time it passes through the ring again? Why is it that after some time it passes through the ring? So after some time, the following happens. After some time, the ball cools. So when it cools, the ball cools. So that is hence reduction or decrease. Decrease in size. At the same time, given that the ball was on the ring, it will essentially mean that there will be conduction of heat. Though this one we are going to deal with it in a different topic. There will be conduction of heat in that this body, it is going to acquire heat, because we say that heat normally moves from a region of low temperature to a region of high temperature. So this one also acquires heat. So the ring acquires heat by conduction. The ring acquires heat. It acquires heat by conduction. The ring acquires heat by conduction. So when it acquires heat, it will essentially mean that it also expands. So that is, when it acquires heat by conduction, it expands. When it expands, it increases in size. So you can see that the ring has increased in size. At the same time, the ball is cooling, and hence the size is reducing. So because of that, you will see the ball passing through the ring. So hence the ball passes through the ring. It passes through the ring. So that is the explanation That is the explanation of that experiment. What is the conclusion? Obviously, the conclusion must be that solids expand when heated. That is what we're having there. Solids expand when heated. That is the conclusion that we can have there. So conclusion, we are saying that solids expand when heated. Solids expand when heated. At the same time, they contract when cooled. And contract when cooled. When they are cooled, they contract. That is what we have there. I want us to go through another experiment, experiment number 2. And in experiment number 2, we are going to use a different setup. So if somebody asks you to explain the ball and ring experiment, that is what you're supposed to have. Expansion of solids. That is what you're supposed to have. Good learners. That is the same of solids. The next experiment, we want to use what we call the bar and gauge experiment. We have what we call the bar and gauge experiment. So number 2, we have bar and gauge experiment. Bar and gauge experiment. So you need the following apparatus. The first one, you need a bar and gauge apparatus. We have apparatus. So we are saying you need bar and gauge apparatus. You also need the source of heat. For this case, we're using the Bunsen burner. So this is how the setup is. So this is the gauge. We have the gauge here. This is the gauge. Then we have the bar. This is the bar. Remember this bar, it has a handle. The bar has a handle. So that is the handle. So we are saying the metal bar. Then we have the gauge. So very fast because of time. So what is the procedure? The procedure is it should be that at room temperature, the gauge just fits. At room temperature, the gauge is supposed to just fit. So that is fit. At room temperature, this bar is supposed to just fit in between the gauge. That is what you're supposed to do. Then you now hit the bar and try to pass it. So I've just picked the last part of the procedure because I've already explained to you. So hit the bar, you hit the bar and try to fit it in the gauge and try to fit it in the gauge. Observe what happens. What are we going to see? So in the observation is that so at room temperature, that is observation. Observation is that at room temperature, the bar just fits into the gauge. The bar just fits into the gauge. Then when heated, the bar doesn't. When heated, the bar doesn't fit into the gauge. So why? So we are talking of explanation, and the explanation is the explanation that we are having here. So in the explanation, we are getting that when the bar is heated, it expands, it increases its size. The bar expands when heated. When heated, the bar expands. So I really realize that we do not have enough time for us to cover something else. In our next lesson, we are going to look at the expansion of different metals, so that we will be answering the equation, do metals expand at the same rate? That is what we will be looking at. But from the discussion that we've had, you've seen that with an increase in temperature, like if they are metals will increase in size. At the same time, when you cool them, you will find that these metals are going to contract, because essentially contraction is the reduction in size. Otherwise, thank you very much for giving me audience, and I hope you have really understood what we have learned in our introduction, and I hope you've also understood how expansion and contraction normally takes place. May our good God bless you. Let's meet in our next lesson.